In the constellation of Leo, a faint star, 120 light-years away, is challenging all understanding of life. The James Webb Space Telescope has swept through the cosmic darkness, revealing planet K2-18b with a 99.7% likelihood of harboring life, not in the form of glittering cities or artificial satellites, but a vast ocean enveloping a hydrogen-rich world, where strange gases whisper traces only ever detected from living organisms on Earth. This is no longer a far-fetched hypothesis. It is a turning point where science teeters on the threshold of cosmic truth, transforming a distant speck of light into a beacon of hope amidst the infinite darkness. K2-18b floats in the vast expanse of space, a distance from bottom Earth that seems infinite, yet feels intimate within the grand tapestry of the galaxy. Its host star, K2-18, a dim red dwarf, lies quietly in the Leo constellation, just 720 trillion meters away, a colossal number, yet close enough for modern telescopes to reach. This star, cooler and smaller than the Sun, belongs to the most common type in the Milky Way, burning slowly over trillions of years, providing stable energy for any world orbiting it. Unlike aggressive red dwarfs that often erupt with deadly radiation, K2-18 is surprisingly calm, offering a rare opportunity for its planetary companion. Discovered during the Kepler K2 mission in 2015, K2-18b orbits its star in a brisk 33 days, a rhythm far quicker than Earth's year, but perfectly positioned in the Goldilocks zone, where liquid water can exist without freezing or evaporating. With a radius 2.6 times that of Earth and a mass 8.6 times greater, this planet is no familiar marble, but a giant melon with strong gravity, placing it on the boundary between a super-Earth and a mini-Neptune. Not alone, K2-18b shares its system with at least one sibling, the smaller and closer K2-18c, which lies outside the habitable zone. It is K2-18b that stands out as the golden candidate, cloaked in the darkness of night, revealed only through powerful telescopes, where faint starlight passing through its atmosphere unveils its deepest secrets. From Earth, the Leo constellation rises in the spring sky, but this planet remains invisible to the naked eye, a silent phantom challenging humanity to peer deeper into the cosmos. This world defies any familiar planetary archetype from our solar system, emerging as a peculiar phenomenon, a Hycean planet where hydrogen and oceans merge into a strange environment, opening the door to life in ways previously unimagined. Hycean, a blend of hydrogen and ocean, describes a planet with a thick hydrogen atmosphere, blanketing a global liquid ocean, creating conditions for habitability despite its alien appearance. This concept exploded from models developed at the University of Cambridge in 2021, where researchers like Niku Madhusudan demonstrated that planets larger than Earth but smaller than Neptune could sustain oceans beneath hydrogen skies, making biosignatures more detectable than ever. K2-18b fits perfectly its size, allows it to retain an atmosphere without collapsing into a gas giant, with infrared data from JWST painting a picture of water vapor, methane, carbon dioxide, and DMS gases primarily associated with marine life on Earth. If truly Hycean, this planet reveals an alien ocean under a hydrogen sky, overturning assumptions about hostile environments. Hydrogen, a lightweight molecule, inflates the atmosphere, making it expansive, and each transit a clear opportunity for analysis where trace gases like methane or DMS stand out against the backdrop. Life here doesn't breathe oxygen or bask in sunlight. It might resemble Earth's extremophile microbes metabolizing hydrogen and methane in the darkness of deep oceans, where hydrothermal vents spew chemical energy. Hycean planets come in two variants: hot ones close to their star, with intense climates, or cold ones with a tidally locked dark side. But K2-18b sits in between, receiving just enough heat to sustain liquid water, possibly with bizarre weather patterns between eternal day and night. More crucially, Hycean worlds may be far more common than Earth-like planets, filling the gap in exoplanet surveys for worlds 2 to 3 times Earth size. The universe no longer needs perfect Earth twins. It only requires hydrogen-shrouded ocean worlds, where biosignatures rise through the clouds, challenging the limits of imagination. The James Webb Space Telescope JWST has become the protagonist in this cosmic drama, transforming K2-18b from a faint dot into a prime target for the search for life. Before JWST, the planet was already notable for orbiting in the habitable zone of a red dwarf, but only when JWST dissected its atmosphere, like a cosmic detective, did we grasp its strangeness. Launched in 2021 and fully operational by 2022, JWST's infrared instruments pierce through gas and dust clouds, analyzing light with unprecedented precision, detecting faint chemical traces in exoplanet atmospheres. Unlike Hubble, which dabbled in visible light, JWST is optimized for deep infrared, sensitive to water vapor, methane, carbon dioxide, and DMS. Each transit as K2-18b crosses its star filters, starlight, through its atmosphere, carrying chemical fingerprints. JWST dissects these with its NIR-SPEC and NIR-ISS instruments, confirming water vapor detected by Hubble in 2019, but pushing further, revealing methane and carbon dioxide that suggest a rich chemical environment. The real bombshell is DMS, a gas on Earth, produced by marine phytoplankton, appearing for the first time on a habitable exoplanet, far surpassing earlier hints of oxygen or methane. JWST deliberately targeted K2-18b in its spectroscopic survey of habitable worlds, aided by the planet's large size and dim star, providing ideal contrast. The data isn't just about gases. It demands complex models to rule out non-biological explanations, emphasizing chemical disequilibrium that requires a constant source, possibly life. JWST eliminates simpler hypotheses with low error margins thanks to its advanced tools and long-term follow-up plans with additional transits aimed to refine signal-to-noise ratios. Beyond gases, JWST maps planetary weather, temperature, clouds, pressure, vertical structure, sometimes more precise than Earth's forecasts. No older instrument could achieve this. Spitzer failed. Hubble saw only haze, and ground-based telescopes struggled with atmospheric interference. JWST, floating at Lagrange point 2, captures pure light, opening a new era where the universe no longer hides. Water vapor first sparked like a glimmer of hope, signaling a world that could be breathable, where rain might fall from a distant skies. Confirmed in K2-18b's atmosphere, this discovery marks a new era, the first time a habitable exoplanet revealed water in its air, not in comets or black holes, but in the Goldilocks zone, suggesting liquid oceans and weather cycles akin to Earth's. From Hubble's vague hints in 2019, JWST elevated the find with sharp spectroscopy, proving widespread water vapor essential for clouds, rain, oceans, and climate balance. Temperatures of 0-30 degrees keep water liquid beneath thick clouds, likely in a global ocean deep under a hydrogen sky, a warm sea where vapor rises to form strange clouds, reflecting light and creating a stormy environment. Water vapor doesn't just support habitability, it amplifies biosignatures interacting with methane, and DMS, making K2-18b a magnifying glass for astrobiology. But DMS is the true shock, a sulfur gas, CH32S, produced on Earth solely by marine life aiding cloud formation and climate regulation. Its faint signal in JWST's infrared matching DMS patterns amid methane and CO2 paints a picture of chemical disequilibrium requiring constant replenishment, a trio of life's fingerprints in a temperate ocean. No volcanic or photochemical process explains DMS at this level in a hydrogen environment. Only biology fits. Yet science remains cautious. The signal could be noise SO2 masquerading, or exotic chemistry. More transits are needed to confirm. If true, this is historic, a molecule tied exclusively to life beyond our solar system, sparking debates about biosignatures from golden oxygen to rare DMS, pushing the boundaries of the search for extraterrestrial life. The 99.7% probability hangs like a sharp blade within the scientific community. Not a definitive promise, but a spark, igniting fierce debate. Behind the near-certain facade, methane, carbon dioxide, and DMS blending. In biological disequilibrium are deep cracks where skeptical astrophysicists clash with the fervent belief of astrobiologists. Bayesian statistics, a sophisticated method, birthed this figure from JWST, data light spectra, filtered through K2-18b's atmosphere, comparing biological and non-biological models, with results heavily favoring life. But the number reflects fit, not absolute truth. And here the rifts begin. On one side, optimists point to the perfect chemical cocktail, arguing that this gas combination cannot be random. It demands a constant source, like the breath of a living biosphere. On the other, skeptics shake their heads at biased assumptions. Models may have favored life from the start, with priors tilted toward friendly conditions, inflating the result. DMS. The linchpin is dissected mercilessly. Is it truly exclusive to marine life? Or could exotic chemistry under high-pressure hydrogen produce it without life? The 3 sigma confidence equivalent to 99.7% sparks excitement in particle physics or medical trials, but in astronomy, it's a large asterisk warning that 5 sigma is needed for a discovery. The debate spills into conferences where heated exchanges compare this to past controversies like arsenic life, reminding us that science isn't a gamble, but a hunt for truth where one misstep could shatter cosmic dreams. K2-18b's atmosphere, a bloated hydrogen envelope full of surprises, not only shields but challenges survival laws where life might lurk beneath thick clouds and raging winds. Hydrogen dominates, making the atmosphere transparent in infrared, turning biosignatures into clear whispers amid cosmic noise. Why JWST easily caught DMS and methane. But beneath this veil, radiation from the red dwarf K2-18 lurks like a predator with UV and X-ray flares that could strip the atmosphere without a shield. This star is quieter than its kin, but sporadic outbursts could still turn the surface into a hellscape, unless a deep ocean, hundreds of kilometers thick, acts as a refuge absorbing lethal rays just meters below the surface. Like Earth's extremophiles near hydrothermal vents, life here might feed on chemicals instead of sunlight, metabolizing hydrogen and CO2 in eternal darkness. Gravity, twice. Earth's crushes the interior, creating a strange, supercritical water layer, neither liquid nor gas, where organic reactions thrive without oxygen. A global ocean stirred by massive tides from the star's pull circulates nutrients like living blood, possibly nurturing microbes at the atmosphere. Ocean interface, where DMS leaks like smoke from a hidden biological furnace. A magnetic field, if generated by a spinning core, or metallic hydrogen under pressure, could deflect stellar winds, stabilizing the hydrogen envelope for billions of years, making K2-18b a fortress against cosmic invaders. But if absent, the planet might slowly lose its atmosphere, gradually resembling Earth, more an inverse evolution where subsurface life persists silently beyond human eyes. Compared to distant siblings like TRAPPIST-1 or TOI 700D K2-18b, stands out not for familiarity, but for its strange allure, where Hycean worlds may be more common than imagined, overturning notions of a lonely universe. TRAPPIST, a system of 7 Earth-sized planets, with 3 in the habitable zone, was once a golden candidate, but its aggressive star spews deadly radiation, likely stripping thin atmospheres into barren rock. TOI 700. Another Earth-sized cousin is calmer, but still mysterious. No gases detected, possibly a dry desert. K2-18b is different, larger, with a thick atmosphere, shielding against flares, maintaining heat despite tidal locking, and easily readable thanks to its bloated hydrogen-water methane. And DMS shine clearly where TRAPPIST-1 offers only faint signals. The low metallicity of K2-18 promotes ocean world formation, where ice and gas dominate over hard rock, suggesting a galaxy teeming with Hyceans, perhaps 5 times more common than Earth twins, with wider habitable zones thanks to heat-trapping gases. They don't need bright stars. A quiet red dwarf suffices for deep oceans to nurture microbial life, perhaps intelligent in the form of soft-bodied creatures, adapted to darkness and pressure. Further searches, JWST paves the way, but aerial HABEX and LUVOIR will scan hundreds, reading atmospheres, hunting technosignatures, like waste heat or Dyson structures. If just one more Hycean flashes, DMS, the universe is no longer isolated. Billions of living worlds await discovery, with Earth as a mere exception. K2-18b is not just a planet. It's a catalyst reshaping astrobiology, turning vague speculation into a data-driven hunt, where the future glimmers with hope and risk. JWST's 2026-2027 revisits will boost signal-to-noise ratios to confirm DMS if it fades. It's not failure, but refinement, ruling out false noise and sharpening tools. Hubble will aid with UV-VLT, will track stellar variability, and Earth Labs will recreate hydrogen soups to test DMS as biological or exotic chemistry. LUVOIR and HABEX in the next decade promise direct imaging, mapping clouds and oceans, hunting technosignatures like radio signals or city lights. Seasonal changes, if detected via light curves, would prove biological cycles. A magnetic field shielding the atmosphere would enable long-term evolution. K2-18b, possibly older than Earth, might host complex life, under hydrogen perhaps, sonar-based intelligence in a dark ocean. If DMS vanishes, science advances lessons from arsenic life or Venus's phosphine. Remind us of the risks of hype, but water and methane remain solid, making K2-18b a lesson. This is a turning point where astrobiology sheds Earth-centric views, embracing ubiquitous Hyceans, revealing a vibrant universe, no longer asking, is there life? But how many worlds have we missed? K2-18b, the first drop in a cosmic storm, unveils a universe, not lonely, but brimming with secrets, awaiting humanity's discovery.